Hi guys, today we're going to continue with translating sine and cosine functions. And just as a review, we introduced this yesterday. The idea of we have a phase shift, which is doing a horizontal translation. And a horizontal translation is going to be written in the parentheses with the function with the opposite sign. That minus means that we move the opposite direction that's written, and that's only if it's in the parentheses. A vertical translation or a vertical shift, it only happens outside, and we keep the sign the same. So that's just a quick little review, and then we're going to look at some where we're just kind of expanding on what we did yesterday. So this is similar to what we did yesterday. We said that if we have a translation, anything added or subtracted, we're just going to kind of draw ourselves a line right here to remind ourselves that we're going to deal with this later. And we're going to deal with this part first. This looks like the kind of equations that we have graphed up until this lesson. So I'm going to graph this equation and then do the shifting. So what I know about this shift, or this equation, excuse me, is that the period and the amplitude is the absolute value of -2, which is 2. And the period, since it's a sine function, is 2 pi over b. So that's going to give us 4 pi. Now, I'm only graphing from 0 to 2 pi, so I'm going to go ahead and put pi and 2 pi on the graph. And if I were to sketch this out, I know it's a sine, and it's also got this negative sign, so a quick sketch of one cycle would look like this. Because sine starts at 0, negative means we start by going down instead of up, and it would end at 4 pi. Well, remember we like these 4 main spots, 1, 2, 3, and 4. We like the beginning and the end, and then we like the midpoint. The midpoint for a sine function tells us where does it cross the theta axis. So in this case, that's at 2 pi. Well, then if I look at the midpoint between the beginning and where it crosses, that's going to be, in this case, the minimum. If it's a positive function, it's the maximum. But this is at pi, and then this would be at 3 pi. So really, based on the instructions, all I care about is to this point right here. So I'm not going to be graphing this part on my graph here. I'm only graphing from 0 to 2 pi. So let me finish labeling this. I like to have at least 4 values on my graph. So that would be pi over 2. This would be 3 pi over 2. All right. So I'm going to put in my 4 points. I've got my beginning here and my end. I know from my quick sketch that the half point is at 2 pi, so it's going to be just this part. My minimum is at pi, and my amplitude was 2. And again, I'm starting by going down because it's a negative function, so that pi is going to go right there. And this is not the final graph. I have to do some translation, so I'm just going to put a dotted line in here. All right, so this is the parent function. This is the green box graphed. And now we need to take care of this part, the -1. This is not in parentheses, so it is not a phase shift. It's a vertical shift. And we're going to move the same direction as the sign that's there. So since it's a minus sign, we're going to move every point down. Well, in this case, that means we're going to move each point down 1. So my beginning is going to go here, and then that's where the minimum will go, and then the end point, will go right here. And so when I draw my final graph, it'll look like that. And so again, this is one of those graphs that looks kind of weird because we're only seeing part of a cycle, and we're zooming in and looking just at part of the small picture. If we were to zoom out and look at the big picture, that's when it would look like it makes more sense. And that's why I like drawing one cycle and like as a sketch and then filling it in on the graph. All right, I know that says 7. I mixed up my examples. Here, we'll go in this order. Okay, so example 6. I'm going to draw a line before any plus or minus happens. So it looks like we are graphing this right here. We need the amplitude. which will be 3. And we need the period, which will be 2 pi over b, and b is whatever number is in front of x. Sorry, I'm not writing that that's a 0, I was making a circle, but that's a 1. So that means that the period is 2 pi. And remember, this means that it will take this long for one cycle. So one cycle takes 2 pi to complete. And then that means that this number right here is telling us how many cycles, or the number of cycles between 0 and 2 pi. That's just a little refresher from graphing, but thought it bears repeating. All right, so I'm going to go ahead and label my graph 2 pi, pi, pi over 2, 3 pi over 2, and then I'm going to do 1, 2, 3, -1, -2, -3. All right, cosine, remember, starts at 1. Although in this case, since our amplitude is 3, we'll start up at 3. I'm going to switch colors. So instead of starting at 1, we'll start at 3 because that's our amplitude. And then it takes one cycle, or one cycle takes 2 pi to complete. So in other words, if I start at 0, my cycle will end at 2 pi. So I have to put an endpoint at 2 pi. Again, those should be the same place vertically. They're both at 3. With cosine, halfway between them is the minimum. So halfway between 0 and 2 pi is pi, and that's where our minimum goes. Halfway between 0 and the minimum is where it crosses the theta axis, and halfway between these two it crosses the theta axis again. Remember, we should not graph this like a V, even though it looks like we could just graph it with straight lines. It really needs to have a curve, and it shouldn't just be like a parabola either. Apparently I can't talk and graph at the same time. Should look like this. Should be real close to flat at the top. Oops, sorry. Real close to flat at the top and then increasing as you go down like that. And then it'll curve back up. All right. So we have one cycle between 0 and 2 pi. Oh, I meant to make that dotted. Let me fix that real quick. There we go. And the reason I made that dotted is because I have a couple of shifting things to do. So let's see. Let's actually change that. Okay. So this shift right here, it's in the parentheses, so it's a phase shift, which means it shifts horizontally. So we do the opposite sign. So this means we're going to move right pi over 4. This one is outside, so that means we're going to keep the sign and it's going to be up 1. Now, right pi over 4 might sound intimidating, but let's look at what we're actually counting by here. I always label pi over 2, pi, 3 pi over 2, and 2 pi, or almost always if we're counting with even numbers. If it's thirds, that's something different. But halfway between 0 and pi over 2 is actually pi over 4. Really, what we've done is we've divided this into fourths. I've got 1/4, 2/4, 3/4, 4/4. But we just simplify. 2/4 is a half, 4/4 is 1. And then we've got, so let me put 3 pi over 4. Then we've got 5/4. I know that the pi's there, it's just easier to say 5/4 than 5 pi over 4. 6/4, simplified. 7/4, and 8/4, simplified. So really, each of these points is moving right 1 unit in this case, if we count by fourths. If you counted by something different, then it would look a little different. I'm not going to sketch that, but usually we're going to be counting like this. I also need to move up 1, so each point is going to move over, or right pi over 4 and up 1. Right pi over 4, up 1. Right pi over 4 and up 1. Right pi over 4, up 1. Right pi over 4, up 1. That was not very good. Okay, I'm getting a little perfectionistic here. That's close enough. All right. So that would be our graph. Notice that when we translate a graph, it should not change its shape. Really, what I should be able to do is pick up this graph that I graphed in the lime green first in the dotted lines, pick it up off the page and like slide it right and slide it up, and it should be exactly the same shape. If you go from a shape like this to a shape like this, that's changing more than just what you're shifting. That's changing something here or changing something here. In this case, it'd be changing this, but so be very careful. Check your shape and see that it's the same from the beginning to the end. All right, one more. We've got to draw our line right here. It happens before any plus or minus. And so my amplitude here is going to be the absolute value of -2, which is +2. My period is going to be 2 pi over 1. Oh, another one with a period of 2 pi. So let's label our graph real quick. All right, so it's a cosine, which means that it starts at 1 and then it'll go down like this, but negative sign. So instead of doing that, we're going to start down here and it'll make a like an upside down parabola. So we have an amplitude of 2. So instead of starting at -1, it's going to start at positive, or sorry, instead of starting at +2, it's going to start at -2. There we go. And let's use this one. Which means that with our cycle of 2 pi, if it starts at 0, it takes this long for this cycle to complete. So I'm going to go over to 2 pi, put a point there. Halfway between those is the maximum. And halfway between those it crosses, halfway between those it crosses. There we go. Now, we need to do some shifting. So we need to shift everything left pi because it's inside, so we do the opposite. And this one we are going to shift down 2. So each point is going to get shifted left pi units. Well, if I look at this first graph, or this first point, it's going to go way over here. So I'm not going to worry about that. This one is actually also going to get shifted past 0, negative. And so I don't care about this one. This one, though, this is pi right here. So if I do pi and I shift it left pi units, really I can count 0 to pi is 1, 2, 3, 4 in this case. So we can also think of it as 4 of those grid marks. Just be careful to remember that you're thinking in terms of pi. It's going to go here. So then that means that this one will go here. This one will go here. And now, instead of just finishing our graph like that, and I know I still haven't done the down 2, don't worry, I need to fill in this graph. So remember that just because we're looking at one cycle here doesn't mean that the pattern ends. We're looking at just a small picture from 0 to 2 pi. It keeps going with that same pattern on and on and on. So I was up here, I came down like this, and so I'm going to continue that pattern. It's going to keep going. And so even though we didn't graph all the way to 3 pi, I can still visualize where that graph came from. So I shifted everything left 2, but I also have to, or sorry, left pi, but I also have to shift down 2. All right, so my final graph should look like this. Again, it has the same shape as this. It might not look it because we see this from the parent function and we see this from the second one. But again, this one actually continues to go like this. And so we're looking from here to here. So it is the same shape.